This is the moment we've all been waiting for. Hardcore people out there. I warned you guys about this one. I'm just saying. Okay, the good news is this is a workshop that was given at reInvent, and I assume people made it through. I actually didn't go to any, I didn't support these workshops when I was there. I'm going to go through some slides real quick. We have from 2:45 until 4:45. One thing you should go back, let me think about this. If you need to go back to your event engine, I guess just give it a try with whatever account you have right now. Yeah, we'll figure it out. Okay, a couple people since the morning workshop asked me about the machine learning certification. This is, yeah, like I said, pretty good one, pretty hard one. To be clear, it's hard in that it's actually real world problems. It's a long exam. The specialty exams are typically 3 hours, and they're an exhausting 3 hours because even just like reading the problem, it's like a full paragraph with a bunch of things, and it's really kind of like a reading comprehension challenge. And then all the answers are complete full paragraphs too. So you really have to kind of like dig in. Fortunately, I don't think you need, I think you only need like a 70% to pass or something. So that's like one nice thing. You don't have to score like a top, but it's about 65 questions, I think. The way I prepared for it personally was I used a service called A Cloud Guru. And A Cloud Guru actually just merged or bought or did something with something called Linux Academy, which was the other big one. There's many partners, training partners. I'm not endorsing one or the other. I'm just telling you guys what I used. The reason I used A Cloud Guru was they have a really good app for my phone, and I could literally be on a plane watching. I could download them to the phone. I could watch them while I was lying in bed, which I did a lot. I did a couple from my bathtub. I just propped my phone up on the tub, propped the iPad up, whatever. And I was able to, crank them out pretty quickly. But the machine learning one, you don't really have to know a whole lot about the things that we spoke about yesterday, like personalize and all those things. You just have to know about machine learning and how to actually, so use it in a real world setting. Okay, get back here. And that's how all the certification exams are, by the way. The SysOps one, for example, was lots and lots of like what happens when your system is completely on fire and you see this particular. So actually my experience from Netflix really helped out because we hit all of the Amazon issues that we possibly could, especially back in the early days. So I knew how to look at all the logs and where in the Amazon system I would find answers. Okay, so I've got about 15, 16 slides here. Today's thing is about, I believe we're doing text classification. We've got a news data set, and we're going to train a model that can then predict based on a snippet of text what type of category this falls into. Is it a business? Is it a global economy kind of situation? So ML AI stack, you guys have seen these slides probably 500 times. Talk a little bit about the problem. Talk a little bit more about NLP and then word embeddings. Very exciting space. I love NLP stuff. Very human, grokkable. We're able to relate to the NLP stuff pretty well. Talk a bit about neural network architectures, and then I want to get right into the workshop because I want to get as far as we can with that. So you've seen this a couple of dozen times. One thing to highlight again, and I think I mentioned this yesterday maybe, AI services is what the like Amazon folks, what like we're calling the higher level, and then ML is kind of the lower level stack. And then these are all the infrastructure. And really, I tend to spend my time kind of straddling these two. If I'm straddling these two too long, I know I'm in a rut, and there's probably a better answer up here between these two. So that's how I think of it. It's very easy to burn cycles, especially because we're all builders. We're all sort of in tune with hardware and like infrastructure. It's very easy to burn a lot of cycles down in those lower like levels, but hopefully you can back up a little bit and focus on the actual problem. So that being said, we're actually going to dive in to the absolute lowest level within SageMaker, which is bring your own custom container. Now, we're actually extending a base container out of SageMaker. So we have the ability to extend like a TensorFlow, 114, 115 base image. That's really going to give us a lot of the pip installs. These are all open source Docker files, so you can go look at them. You can scan them with your own like Docker registry scanners, whatever you got to do, harden them up for your group. But really what we're going to do is slurp in our train.py file and then run training. We'll also do inference as well too. So there'll be a train.py file, there'll be a predict.py file as well. Okay, to hammer this home, SageMaker has these things called built-in algorithms. So funny enough, or sort of interestingly enough, about 5 or 6 years ago, yes, Amazon released something called Amazon ML service. And really lots of these were actually already in there. And my personal feeling on this was people weren't really ready for that, right? Any people that were doing really hardcore machine learning back then didn't want to use the Amazon ones, right? How does Amazon know my problems, right? So people really stayed in those lower levels. All the people I was working with 5, 6 years ago, yes, I was building the custom like scikit-learn models and like TensorFlow models as of 2015, 16. And these services have now been sort of reintroduced and updated as part of SageMaker. And now these are actually becoming, so there was kind of a 4 or 5 year period where we were all building these things ourselves and then finally realized, oh, wait a minute, I don't have to build these things myself. I could actually just point my data, to my data and then have all this done for us. So obviously they've been updating the algorithms for object detection and the image segmentation and some blazing text, which is actually a variant of fast text, which is an implementation of word2vec. It's kind of the like lineage there. Classic principal component, random cut forest, deep AR. So these have actually been here for quite some time, but they just have sort of resurged in the last couple of years under SageMaker. All right. One thing you see as a common theme with anything Amazon is, you could do everything in the console, but you probably want to script it at some point, make it part of a pipeline, some sort of automation pipeline. Obviously there, as part of, there's these new pip installs. There's like pip install SageMaker is not fairly new. That's about 2 years old, 3 years old. But there's pip install SageMaker experiments, which is for experiment tracking. Pip install model, I think it's pip install SageMaker -debugging, where you can debug models and like do this right in line with your Jupyter notebooks. Actually, that's what I wanted to do real quick. I want to spend a couple minutes on a recap from reInvent. Desktop. Is this it? Oh, hang on a sec here. Moved it to the wrong place. There was a bunch of new announcements that I don't think were really emphasized well. Where's the recap? Recap PBTX. So these are all the new announcements for the machine learning side of things, and looks like networking and storage is in there as well too. Let me see if I can make this bigger. I don't think I can, it's PowerPoint, but yeah, so lots of new stuff. I think we've talked about some of these yesterday, like recognition, custom labels. I was just talking about the experiment tracking within SageMaker, which is a pip install that can be used outside of it can be used in your own like Jupyter notebooks. The debugger for model debugging, autopilot is the AutoML. Model monitoring, there's an operator now for like Kubernetes, like a custom integration for like doing machine learning inside of Kubeflow pipelines, Kubernetes pipelines. You've got SageMaker Studio, which is a nice IDE that's actually based on like Jupyter Lab, and it has all of these things built in, but you don't need Studio to actually do these. Studio is in preview. We don't have access to it within Event Engine. It's only available in US East 2, which is Ohio. There's new SageMaker notebooks that have actually been like reintroduced as part of Studio that are like truly serverless. So yeah, up till now, when we create a notebook, we're specifying a notebook instance, and it's occupying an entire instance, and we're, like trying to optimize. The newer versions of SageMaker notebooks, which we are not using today, are truly serverless. They run for only the life that you're running the actual notebook. It's more efficient utilization of resources. It's cheaper, and you like truly pay by the minute. Okay, there's some deep racer stuff going on. There's a lot of stuff that's been happening. Contact Lens for like Amazon Connect, which is like customer service, customer support sort of system. There's a lot of machine learning that's going in there. Also, the second one down on the left is the Amazon Code Guru. Yeah, did anyone talk about Code Guru? I don't think we talked about it yesterday, right? This is a way to do, well, yeah, I'll just show you guys. Okay, this is the full recap deck, which is available online here. Okay, people get pretty excited about this. Code Guru. This is the holy grail of you have a code base, you want to, and this is a bit controversial also, by the way, this is going to bring up a lot of comments, but we can point, so Amazon has trained Code Guru on 15,000 open source projects, and what they're training for is quality of code and things like security, right, like potential security threats in the code, performance inefficiencies. So we're kind of finally at that point where we can point this like Code Guru to our like private GitHub repos, and actually this can build intelligent code reviews and can actually create pull requests to submit. Yes, obviously they would be human reviewed and then analyzed, but this is based on very, very large open source projects. Yeah, I'm going to be very upfront and say right now this only supports Java. Yeah, like waiting for the big, right? Does not support Python yet, but Java. So you can imagine, and I don't know this for a fact, but this has probably been trained on the Spark code based, which is very like heavily JVM based. And many, many very popular Java projects. And so I'll show you guys more how this works here in a sec, but there's the static analyzer, which is the Code Guru, yeah, that's the reviewer side of it. So that's physically just take a look at the code and tell me what you think. Are there inefficiencies? Am I using the wrong regex package? Is there a faster way to do something based on what I've seen in these 15,000 other right, like GitHub repos? And then there's the runtime, which is Code Guru Profiler. So this is actually, while the code's running, there's an agent on there. If you're familiar with something like App Dynamics, where you would have an agent running on each machine, could actually identify in real time either memory leaks or potential places for like performance improvements. Okay, so there's a static and a sort of dynamic runtime aspect to this. Okay, so it looks at source code. It's looking at semantic patterns. It's looking at similar code for comparison, and then can actually create a like pull request. So classic example, something very easy to do wrong if you're not hip to proper concurrency and callbacks and other things. And so what's cool is there's actually someone took the time to actually create these links. So it's going to say, hey, we found something. Yeah, here's a recommendation, and then here's a link off of the Amazon blog to show you why this is poorly written or how this could be better like implemented. Okay, there's some, you could tell this is probably on some internal code within Amazon somewhere, but classic regex issue. It's very easy to do slow regex. Yeah, I know this personally from my days at like Netflix. We were always, it is or was, and I think still is, a big Java shop. And this has seen this problem before and said, hey, there's a faster way to do it. Just change this one thing. They claim on this next slide here that Amazon actually benefited. One of their changes, this particular change, I guess, actually increase utilization, which is a good thing. You want to increase, and then lowers costs by 39%. And this was for Prime Day 2017 versus 2018 after this particular inefficiency was found and then fixed. Okay, I'm going to skip over Kendra. It's pretty interesting stuff, but here's Studio. So again, we're not using this today. Parts of it are, it's preview, so it's not necessarily prime time for this kind of large event, but if you do want to explore it, go to US East 2, which is Ohio, spin it up. The cool thing is it has shareable notebooks. What else? It has the experiment tracking built into it. And so, if you notice, if you've ever used Jupyter Lab instead of just plain Jupyter, you'll notice this is actually based on Jupyter Lab. So I was really happy to see that the Studio team chose Jupyter Lab, because it is much superior to Jupyter, in my opinion. You can have multiple tabs up. So these are actually these are different experiments running. You can see them charted. You see the hyperparameters and see the metrics. There's a debugger now too, so you could actually sort of see how training is happening as the model is being trained. So here's a similar model to what we did in the morning, where we have the estimator TensorFlow passing it the notebook that's spun up here runs in its own Docker container. That's the serverless part of the new SageMaker Studio notebooks. That's good and slightly bad, because it's good in that things are isolated and serverless. It's slightly bad in that it's different than how we use notebooks today, where we will write a file into a directory. If we go into another notebook, it does not have access to that file because they're physically separate Docker containers. There's ways around it, of course. You use S3. There's ways to share the file system. More will be coming from the SageMaker team on that. Best practices for that. Sorry?
When does Studio go GA?
I actually don't know when Studio goes GA. Model monitor. So this is actually this is the model in production. This is the model that's in service. These are the model endpoints. So you can imagine how this was implemented. There's a like REST API out there that says get me the experiment, or get me the endpoints. The same one that's used by the console, right? When we go to look at the endpoints, and it's showing the status. And it's a slight little tip. Right before I joined Amazon, I started a company, and like we were doing all of this. So like I understand all the problems and all the challenges around this. And Yeah, one of the reasons I actually joined Amazon was because all of the stuff that was on our roadmap is now seen here. And it just makes me feel so good. So yeah, this is great. This is autopilot in action. So here we're not just picking hyperparameters, but we're also picking which model to use. So that's the difference between hyperparameter optimization and AutoML. With like AutoML, we could actually explore like multiple model types, right? Like different algorithms, and not just one algorithm with different hyperparameters. All right, so that was kind of a whirlwind update there. Let me go back to here. Okay, SageMaker SDK. We've been using this. This is what we used this morning, basically. Okay, word embeddings. I don't particularly like the way it's presented here. Ooh, it's presented here. How do I get rid of that thing? But I explained them earlier. So, and then NLP. Okay, so here's problem definition. We have news classification, these different categories. I think B is for business, and E is for economics or something. There's, yeah, different ways. So title, category, the URL, host name, and there's text, of course. Yeah, B is business, T is technology, E entertainment, and health and medicine. All right, this is essentially what we're doing right now. This is roughly the structure. If you want to take a picture of this, or just yeah, you'll see it here in a bit inside the notebooks. So again, this is our train.py. There's no .py there. I don't know why. Yeah, this is somebody else's workshop. I didn't want to muck with it too much between last night and today. I just made sure that it worked, which it does, barely. Excuse me. Here's the predictor.py. This has a function that can predict and can also convert, this can convert raw inputs, can take JSON and then convert into whatever's being used by this model, if it's a tensor or a NumPy array, and then same with the response. It can actually take that tensor and convert it into JSON to respond to the caller. We're using Glove in this case, so this is this is Glove-based data set. And essentially, we're going to build a Docker image. One of the tricks to this workshop, read very carefully, make sure that you add the policy to gain access to ECR. That's the Elastic Container Registry. It's like basically Docker Hub, but private per account. Yeah, everything goes to S3 at some point. This is the main notebook that we'll be running. We're also going to be doing quite a bit of command line for this workshop. So please help each other out. Yes, I know yesterday I would talk to people that have the exact same issue that were sitting right next to each other. Please ask and try to help your neighbor for this one. There's a big mix. There's people that know command line, people that aren't familiar with command line. This is more command line certainly than the stuff we've seen to date. So, all right, like enough scaring you guys. So have at it. Go to this link. We're going to start off exploring the data, which is actually very simple. We're then going to build a Docker container. We're going to simulate as though that container has been deployed into SageMaker. So keep in mind that we're building a Docker container that runs inside of SageMaker. So SageMaker is all container-based, and right, like behind the scenes, it's all containers. We're taking our own custom container, and we're slurping in our train.py and then predict.py, and then pushing it out into SageMaker. One thing that always confuses me about SageMaker, they have this thing called script mode. This sounds really wonky and goofy. Yes, all this means is you're providing train.py. Okay? The opposite is, what's it called? I think if it's not script mode, it's like built in, or there's some other term for it, but okay. So grab a picture of that if you can. Or just go to it, make sure the tab is up. And then I want to walk through. So we're using Keras, but like I said earlier, Keras is actually part of TensorFlow now. I believe the instance type is different on this one for the notebook instance. I think it's a T3 medium. You could probably use, well, yes, I would follow the instructions like verbatim on this one. If you can get back into the event engine, if you go to that dashboard.event engine, you could try it with your personal. I'm a bit nervous. I only know that it works with event engine. So I'm going to keep this up for another minute, so take a picture or something. And then I want to go through it. Part of this has VI commands through the terminal. One of the things you'll get potentially stuck on is make sure that you edit this capital region. Make sure, so you're going to create this file here in a bit through the terminal. Make sure that that gets changed to US-East-1 or whatever region you're running it. I'm going to jump ahead here on mine just to clear the path a little bit and then come back and do it with you guys. Also note that this particular workshop, the author has chosen to use relative. If you do things out of order or have to go back, you are likely going to end up in the wrong order here. When I do my workshops, I always do everything absolute from the root because I know if I run a command anywhere, it's going to run. So yeah, a little tip if you're creating your own workshops. This isn't a good practice, just because if you're trying to recover, end up in the wrong place. So keep an eye on that. Usually what I do when I get stuck is if that command doesn't work, I go back up and look at whatever directory I was at before or need to be in. You will likely see, this is subtle as well, you'll likely see something that says, are you sure that you want to remove the write protected file? Ugh. What's happening? If you see this, just say yes. The author of this has a note in here saying this is okay, but it looks really scary. When you run the Docker build, it's doing some fancy stuff in the scripts. Yeah, one other thing not to do is create magic scripts because they tend to hide things. And so yeah, this is trying to remove things to keep things clean, but it's a little scary. But yeah, just say yes. This is all running inside of its own directory and its own container, so you should be okay. Yeah, the other thing to note too is some of these lines have lots and lots of ampersand, things that you're supposed to be running at the command line. If you don't know that, you might accidentally only copy the beginning, or if you're trying to debug it, just note that this particular author has put one line of 8,000 characters and a bunch of commands. Typically would break them up or show output. Also, one other best practice, just since we're on the topic, is anytime that you write something that's doing something significant, you should then verify it, right? So when you're in a large group like this and something's wrong, I could quickly look at someone's screen and say, oh, okay, like confirmation step didn't work. So instead of concatenating all these, I would break them out separately and then print out things that I'm generating. So hopefully you guys got the notebook up. And you would start here. There's really only a couple things that you run here. Then you stop and then go to the command line. If you're at this step of downloading the data, if you chose to go this route, there's two routes that are described. The first one, they're ampersanding the unzip. Okay, yeah, let me start over. Step 5, this is the first place people might get hung up on. This is a very, very slow way to download the data. But they have ampersand unzip, that name here. Actually, this one's fast. So yeah, just use that one. It's this one here. If this is taking a really long time, you could switch to this one, but this unzip doesn't work anymore. Okay, so someone added this step to make it faster, but didn't complete the thought with the ampersand, okay? So you would have to unzip it yourself, figure out what the files are. There's going to be a glove file. It's going to be in a subdirectory. It's a little bit of confusion, but if you want to be safe, just wait for this one to finish, and yeah, you'll be fine. And then make sure that you run this step too, where you clean out those like unnecessary files. If you do go this route, for those of you that are choosing to download this faster, these files end up inside of a subdirectory. Move them out back into where they should be from that step. And I would recommend reading this stuff here as well too. Category is our target column. Oh, and then here, yeah, they're actually only using what's in the title to predict the category. Title URL, oh. Title URL, publisher. Okay, this might be a good time to mention there's these SageMaker containers, and like I showed on the slide, we're doing this. Whoa. We're actually extending these SageMaker containers and putting in a little bit of our own extra. And the reason that you would do this is if you need to train and you need access to an ODBC-based database, right? Like a SQL Server database. And these base containers don't have all these core TensorFlow containers. If you stick to just TensorFlow and very common situations, you can then use that. If you're doing stuff that's very specific and you have to install your own data source connectors of some kind, then you would likely want to extend. You could completely build your own container from scratch. But when you get to that point, you'll see we're actually extending the other Docker container. That's this part here. So the way Docker works is you could take anybody else's Docker, Docker image, and you can start with that as your base, so from, and then add in your own, this is installing Nginx, this is installing Flask. Yeah. And then don't forget to change that to the region. Also, don't forget this region down here. Make sure that you drop the, right, like less than, greater than. This whole thing should be replaced with just US East 1. Now this command will actually generate a big blob that starts with like the word Docker. What this is doing is it's generating the command that's required to authenticate with the ECR Docker registry, which is where that base from thing comes from. Okay, so like I said differently, and there's a sort of conventionally better way to run this command where it does everything all at once. For some reason, this is doing it the harder way, but this will print out, copy that entire Docker with the blob. It's a token, and execute that. That's what this statement here is. Copy and run the output emitted by this command. It starts with the word Docker, and it's going to be Docker login something. Once you do that, then you could actually do the Docker build. And then this is where the ops folks in here will get excited. What this statement means is Docker build. So yeah, obviously like we're using Docker. We're saying build. The command that was generated up here was Docker login, Docker build. There's Docker push, which will push to the repo once we're done building. But this is saying tag. This dot means what's in my current directory. There has to be something that's called Docker file. This is just a convention that like Docker uses. So that was the Docker file that we created up above. So dot just means here, right where I'm at. Hopefully, you know, again, we're in the right directory based on how we got here, but if you follow these perfectly, you will be in the right directory. This is going to build this Docker image with this name, and this is a tag. And latest is a Docker convention. If it's called latest, there's some special, there's some shortcuts you could take when you have a Docker image that's labeled latest. I never use latest because this gets people into trouble. So I purposely do not have latest. But for workshops like this, it's fine. It's very easy to like accidentally pull in the latest when you don't intend to pull in latest. So next up, we're testing. Let's see, test of training and info. Okay, right. This is going to actually, so that we've created this Docker image, and we want to test it out before submitting to SageMaker, which is going to incur some cost, you know, tiny bit of cost. It's going to, you know, take a few minutes to run. We can actually run it locally just to get like a smoke test, just to understand that this thing is even, you know, seemingly starting properly. So follow these commands, wade your way through that, cd into that, and call this. So train local, if you're curious what's in train local, you can run, you know, cat, or you could vi train local, see what's in there. Again, it's a magic script. These always make me nervous. They're probably setting environment variables and all kinds of stuff that it's going to be hard to debug. But so that's going to run train local. It's going to use that Docker image that we just built, and you'll see this run for a couple minutes. Now this is actually running in the notebook, right? We're in, just to level set here. we're actually in a terminal on the notebook instance. So this is not using SageMaker training. This is using SageMaker notebook, but it's actually just running it. And hit yes to delete those write protected files. And now this is actually training, but it's training using the notebooks like resources, which is not how we want to do this long term, but we're just smoke testing before we submit it to SageMaker. Yeah.
So I came up to
One thing that you may come away with after seeing this like workshop is you shouldn't have to go through this kind of stuff, right? You should only do this in extreme cases where all the stuff that we've done up till now isn't going to work for you. And from talking to like quite a few of you, I think a lot of your use cases actually do fall in. And I'm speaking as a wounded soldier in this battle. The last, like 3 years of my life, I spent like debugging these kind of error messages and getting like Docker to work with GPUs and getting Kubernetes to work with GPUs, and it's no way to go through life, right? There's a lot more interesting problems out there at the business level. Okay, and then what's happening here is they're saying, if you want to, you could actually, modify and try different things here. I would actually skip this section. This will be, this is creating like another Docker image. It's not really all that important to do that. I would move on to to this part, the inference. So what's happening here is there's a magic script that says serve local. If you want to crack that open and see what it's doing, and then passing the name of the Docker image with the tag. The only tag that we're using today is this latest. When they build the other version up above, which is the step I said to skip, they're actually changing the name of the Docker image. When you do run this serve local thing, so I'm going to clear my terminal. I'm running serve local. Of course, I'm not in the right directory. Serve local, this script right here is starting up and it's occupying this terminal. So there's a little note in here that says open up another terminal. Make sure that you do this. Make sure that you read carefully. That terminal has the server running with the model that we just trained. So you'd have to go up here, somehow navigate back to where you can open up a new terminal. Down there. Once you're in that new terminal, change directory in there, and notice that there's, oops. So from a different terminal, we passed in this JSON that has this title, why exercise alone, and the prediction comes back, this is health and medicine. Okay, so the model seems to be working. So now it's time to deploy to SageMaker. So that's what lab 4 is here. So for lab 4, we go back to the notebook. And in this case, we have one gigantic cell that's running a whole bunch of commands, including Docker build commands. So just to kind of level set and to set the context, we've smoke tested our Docker image that we built inside of the notebook instance through a terminal, very small node, a T3 medium or whatever. That's obviously not how we're going to deploy the model, but we're just testing it just to make sure it's not crashing. Now we're actually going to train and host using our Docker image in SageMaker. Our Docker image, our algorithm has been packaged into this Docker image and will now run on the managed service called SageMaker. The run a separate terminal is, it's 3. This is where it says to open the terminal. The reason you have to do that is when you run this in one terminal, this is going to basically block that terminal. So you'd open a second terminal to run this command down below. And make sure that you capture all of this command here, because really it's doing a change directory and it's printing out the input for your benefit to see what the input is, and then the prediction is at the very, very end. So make sure you grab all these. If you're savvy at the command line, you'd break it up and run them separately if you want. But that'll be run in the second terminal. Yeah, so please help each other out. If you see your neighbor struggling, so lab number 4, so this is where we're going to actually deploy it to SageMaker. We're going to take that Docker image. I would skip this part. Yeah, this is saying, okay, now that we're going to do this outside of the notebook, we can bump this up to more epochs. I would skip that. It's just going to take longer. I would keep it at whatever, 2 or 3, whatever it is, if you don't want to bother with the VI and stuff. And then, so lab 4 takes you back to the notebooks, which seems counterintuitive because all it's doing is running a big shell command. So by the way, this is the equivalent. You could do %% bash or %% shell, yeah, sh. We could have done all those commands here. So whoever created this, either someone did this part of it, and then the first part someone else did. I don't know what happened there, but you could actually have run all those inside the notebook by doing %% bash, %% shell. And all these things work. Like you can even reference, with Jupyter Notebooks, you could do like $, and then reference Python Python variables that were created before it, like region and. Okay, so let's run this big thing. When you run this gigantic cell, this cell, I thought it was broken last night when I ran it. It runs for a couple minutes and gives no output. So if I put my best practice for workshop hat on, I would say break this up into multiple cells. Show me the output at least so I know something's happening, some progress. And then verify. Print out the thing that I just did. If I'm copying to S3 or from S3 or I'm grabbing the region, print the region. So I see that it's the region. Then if I go around and I don't see region showing up, then I know the cell before it is busted. This is doing too much in one. Here it's actually restarting Docker from within the notebook. I don't exactly know why that's happening. There's a comment there, so something must be weird. Build a Docker image locally on a SageMaker. Let's see what that. So one of the sad realities of this particular way, or this low-level approach, is you really have to know where you are when these commands are running. You have to know that you're in the notebook instance. You have to know that when you call Docker, you're actually using the underlying instance's Docker that's been, the hole's been poked through. Okay, so this looks like it completed. What we did here was created a repo. So this is ECR repo. So if you recall on this, let's see, on this diagram here, so we create the Docker image. Now we're pushing it into ECR. And then when we launch the SageMaker job, we're going to give it the coordinates of that Docker image that we pushed into ECR. So before we push it, it's just sitting on that notebook instance. Again, you kind of have to keep in mind where you're at, where the actual assets are, these resources. So this push, if you look at the very bottom, it should have the push command. This push command pushed into this Docker repo, or this, ECR repo. You could verify that if you go to ECR in your console. So the Elastic Container Registry, go here. And you should see the Docker repo. And this is the exact coordinates. So similar to, if you're familiar with like Maven coordinates, Ivy, Spark, right, like packages, things like that. You have some registry that contains the Docker image. When we go to launch SageMaker, or launch that image on SageMaker, that's how we tell it which image to use. And this image has to have the train.py file and has to have the other conventions that are required for this lower level usage. Okay, so the rest of this, at this point, and this is a good thing, so the rest of this actually looks like what we had been doing up till now. Right, like all morning, all day yesterday. Well, yeah, sorry, actually just this morning. So let me point out that this is the estimator. Yes, one thing to note, they've actually aliased SageMaker as Sage. So if you see Sage, that's... All right, so check this out. So this is the exact same estimator that we saw before. We're giving it the same types of things. We're giving it one instance, the instance type. We're telling it where to put the output. Session's optional. It'll use the session that's in context otherwise. But we're also passing image. And this is our image. This is the one that we created. And they should have :latest here, but they don't. And so by default, it's pulling the latest. So never use latest. I would rather error out that they didn't specify the version than to rely on something called latest. So we've now, let's launch this. Did this train the model, or did this fit? What happened here? Oh, yeah, there we go. Okay. So this is running our image on SageMaker and doing the training. And from this point, it's the same thing that we saw this morning. These logs will get captured, will get sent to CloudWatch. We can then compare, we could pass hyperparameters here. And then when that's done, we'll then deploy it. Tree is just what they call the type of, that's just a variable name that they chose. This is the same as like the MNIST estimator or whatever, but this is for this text classification. So deploy that and then run the predictions. Yeah, has anyone gotten to the lab 5? Yeah. Yep.
And I'm testing the inference code.
Yep.
I already
Is anyone having problems building the Docker file? Or building the Docker image? Seen a couple of people with issues. Okay. add on LinkedIn or whatever. I don't have my phone on me, but
Or email address.
yeah, so it's my first
See.
initial. Okay, some folks are starting to leave, so I just want to mention these accounts, the event engine things, will go away. I think they're scheduled to go away right at 6 o'clock. Everything is reproducible for this workshop. Everything can be reproduced with your own account. You might have to change some of the instance types and things like that. And I'll show you. So, things like this, if it complains that you don't have enough M5s or something weird, it'll tell you right away. This won't even fire off. And then just either change it and just know, M's are high memory, C's are high CPU, P's are GPUs, I's are I/O, so used for like Spark workloads, that kind of thing. Typically, we use a lot of C's and P's. P's are expensive, so try to stay away if you don't need GPUs. C's are a good way to do it. Let me see. There was one last part here. Okay. So this script mode thing is kind of interesting. So we actually had a train.py that we slurped into our Docker image, right? If you recall in this lab, it was one of the things. Let's see. Cd container. So this is our train.py. This got slurped into our Docker file. And yes, I want to point out, because I saw this come up a couple times, if you see errors that are /opt/ml, so that's a directory inside of the Docker container. That's not actually going to, and it's being mapped by the SageMaker framework to, there's 3 special directories. And these are all very, very well documented, by the way. They're right here, actually. So opt.ml output. This is where output of, this is where the trained model will get put into. Model is where the train.py goes to. And then there's input. And so actually, someone over here had this problem here where it couldn't find input config, right? Yeah, was it you? Yeah. That means, I don't exactly know what it means, but it means something that's needed. Yeah, something wasn't mapped. So the container only speaks in terms of opt.ml and then either input, output, or model. If those are not mapped properly, and that's usually because it's like likely that the directories got out of sync during the Docker build, something happened where it like wasn't able. Yeah. Anyway, so just know that when you see opt.ml, and you could find that on SageMaker, Docker image opt.ml /boom. It's like literally part of the SageMaker documentation that if you do go this route, you have to know about these directories. So there it is here. Opt.ml model, opt.ml input, model code output. I forget what code is. Actually, yeah, if we zoom in close enough, it actually looks like someone cut and pasted this into the official image. The word code's a little cut off there. Oh, yeah, so here it is here in kind of ASCII form. And these are mapped from the outside world. So, Docker has its own stuff going on inside, and it gets these paths get like mounted to the actual host. And that's supposed to be done cleanly for you, but in a couple cases, those got out of whack. There's also something called script mode, and script mode is actually what we used this morning. So here we built this heavyweight Docker image and told. So I'm going to do a side-by-side comparison to tie everything together here. So that's today, or that's this afternoon. This is now. This is this morning. Yep.
We'll need the video. I have the link.
Okay. Oh, cool. Thanks, man. Yeah, you've been super helpful, by the way. Thank you. All right, let's open Jupyter. Okay, side-by-side comparison here. Okay, so on the left was this morning. I showed you guys what we were doing is actually called script mode, where we're giving it what's called an entry point, and that stems from right, like the association with Docker. Yeah, so Docker file. Yeah, so Docker has something called an entry point. And this is our train.py, basically. Here, we're also like using this feature of SageMaker, of these estimators, that's called source dir, where I can put in, right, like requirements txt, which is how I could do all the pip installs. So I'll drill in here in a sec and show you the requirements txt. Then I'm setting up all the usual suspects, instance type, the number of instances, the version of TensorFlow that's being used, Python version, script mode equals true. So I didn't really mention this morning because it didn't really make much sense until we saw non-script mode. So non-script mode is we create a Docker image that has the script burned into it. So like beneath the covers, this is actually happening. So always prefer script mode if you can. If you have to do ODBC drivers and other stuff, then go like your own route. There's actually been some work recently where you could specify a right, like shell script as part of script mode. So not only will it slurp in the requirements txt from that folder, it will also run an arbitrary like bash file that'll do apt-get install ODBC. Okay? So if you find yourself doing this, double check that you, and because really, right, like you don't want to have to manage all these Docker images if you don't want to. When I was building this 3 years ago, something like this, we had customers that actually wanted to version these Docker images. And they would put it into something like Artifactory or like ECR, and they would treat it like a database. So they could version the exact Docker image, they could pull it out at like any time. This gets really, really bloated really fast, okay? So try to do that beneath the covers, serverless, managed for you. Okay, so hopefully you understand script mode a little better. And there's a distributed version of this. And really all you have to do here is just pass in this little JSON blob. So we actually did this morning, I think, but I didn't highlight it. Yeah. So we actually did distributed TensorFlow this morning, but only using one instance. Yeah, right. Like, did anyone try 2 instances this morning? Did it work? Yep. Cool. The thing to know if you do multiple instances, If you remember, there was output coming from here, from this fit. It was showing the console logs. They'll show up in different colors. There's one color log, the log color will change like depending on which instance is logging it out. So said differently, I could see all the logs from all the instances in one place, and they'll be separate by color. Okay. The first iteration of this chose red for the first color, so it like looked like there was errors everywhere. They've since changed it, I think, or it's like a pink or something now. It's a little softer, but. All right, we're at 4:30. Trying to think if there's anything. Any other questions? Yeah. Yeah. Yeah, why, so the question is, why would you want to go this route? So one thing, so the thing that we were doing inside of our Docker image, our Docker file, if we look at the Docker file, let's see what they're doing here. And this is actually a dual Docker file here, where they're using the same one for serving that they are for training. Why we primarily were building our own images were certain customers have their own way of doing this kind of thing. I mean, this is just doing like web requests, or there's a custom agent that they need to log to Datadog, or something like that. But yeah, like I said, the script mode, they're starting to add more and more flexibility to script mode, where this becomes less and less important. The other thing is, if you go and look at these Docker images, SageMaker, deep learning container image, Docker file. Yeah, again, these are all open source, so you can go look at these. Oh, yeah, I should mention, the obvious one that I always forget to mention. If you have custom security requirements, something that really requires you to comply to some other base images, then you don't want to use the SageMaker ones. There's people that'll flat out never in our lifetime use the base SageMaker images. They just won't do it, right? Because of some issue. Trying to find the actual. Docker. These seem like older ones because they're mentioning Docker 13, but this is the gist here. We've chosen from our experience how to actually install these things, but really, certain customers might not need MPI, might not need a lot of. It's tough to find a good balance of appealing to a lot of customer needs, and then also to a single customer. So yeah, the short of it is sometimes these are just bloated. Any other questions? Oh, and then I've also seen other people where they have really good experience with a different version of Python, not version number, but a different distribution of Python. So I've seen this where they've been using the Intel Python for so long that's been optimized for Intel CPUs, and they know the performance characteristics of it, and they don't want to use the particular distribution of Python that is being used in the base container. Or Java, if you have a JVM, or sorry, the JDK, 1.16 that you're trying out, 1.14, whatever. Yeah, they're up to now. I guess the last thing to point out is if you go to PyPy, this is where you do, when you do pip install, this is where you go. Or yeah, this is like ultimately what's coming in. Keep an eye on the SageMaker stuff. There's actually quite a lot out here. SageMaker experiments right here. This is the experiment tracking. These are things that you can pip install right now into your notebook and start using. Let me show you. This is a private repo, so forgive the stealthiness here, but SageMaker. So looking for. Yeah, this notebook's not fully ready yet, so it's in a private repo, but let me just kind of show you what we're getting at here. We've pip installed SageMaker experiments. This is all pretty much the same except for here. So now, instead of training, we're actually creating an experiment. And this is actually calling into the SageMaker experiment API. So this is hiding all the, like SageMaker experiment Python calls. And I could just tell it, create this experiment and do a bunch of runs within the context of this experiment. So here's so this is PyTorch, but here's that same exact fit, or the same exact estimator call, but now we're running it within this experiment. And then from there, once the training finishes, I could query the experiment. So this is what SageMaker Studio has all integrated, but this is how you can use it outside of SageMaker Studio if you want to just use it in your own. Okay, and here we're going to actually analyze the experiment. And this is just a sample pandas data, or a simple pandas data frame that shows the actual run, the ARN to get to that specific run. So this would be this is a PyTorch training job within SageMaker, similar to what we did this morning, telling us the hyperparameters. Here, the only hyperparameter was number of the epochs, and then telling us our validation accuracy, average, min, max. So this is what SageMaker Studio basically is doing behind the scenes and showing inside the nice IDE. From that point, I could ask for, I could do hyperparameter tuning, tell it to optimize on accuracy for this, and then I could say, get me the best job of this hyperparameter tuning run. So I'm hoping next time I'm back here in a month or two, I'll have all this stuff working for you guys. Okay. Yeah, all the slides will be shipped out, I think, later tonight. Yeah, tomorrow. Yeah. Thanks for coming. Happy New Year. Oof. Hey, oh, it's a race. Yeah, quick is a, yeah.
I have a quick question.
Okay.
Not related to this ML thing, okay? So I'm trying to build a data lake on it.
Oh, God.
Right?
Yes, one sec.
No.
Yes, is it quick?
Oh, no, go ahead.
Okay, yeah.